Hello and welcome to another video. Happy New Year to every subscriber and everyone watching this video in 2023 or any year after 2023. Okay, this is an integration problem, and like I've said in other videos, whenever you see a function that is a combination of functions like this, and you're supposed to integrate it, if the integrand looks like something you would use chain rule for, or use the product rule for, or use the quotient rule for, when you're differentiating, the first option you want to consider is U substitution, or what we generally call change of variable. I like U substitution rather than trig substitution, unless trig substitution is the only way. But if I can use U substitution, I just set the trig aside. So looking at this, you want to look at the two functions. And my first strategy would be, I'm going to write this as a product, okay? Because every strategy we take for U substitution is usually a product. So let's try and write this. Which one is more complicated? As you can see, the top part is more complicated than the bottom. So it's more likely that the top part is what I'm going to take as my U. How do I know that? This is how I make my decision. If I differentiate the square root of x, does it give me something that looks like this? No. But if I differentiate the top, will it give me something that looks like this? Yeah, it will contain it. And if your derivative is going to contain the other portion, then you might want to take that part as your u. So I'm going to write this way. I'm going to say this is the same thing as the integral of 2 to the square root of x multiplied by 1 over the square root of x dx. This and this are the same. So I'm going to try and differentiate this and see if something like this is going to come out of the derivative of this. If I see it, then that's my way out. If I don't see it, then there's trouble. Let's get into the video. So our first move is going to be, we write our u to be this one. So we're going to say let u be equal to 2 to the square root of x. So now we need to differentiate this. Now for some people, differentiating this might even be a problem. Now, some people memorize how to differentiate this, but the problem with memorizing is when it gets more complicated, you don't know what to do. So this is what I recommend. Whenever you see an exponential function, introduce natural log to bring this function down. So just take the natural log of both sides. Okay? If you take this natural log, see I've taken the natural log of this and the natural log of this. This stays as the natural log of u, but this comes down, it becomes the square root of x times the natural log of 2. So something you must watch out for is that, see, this is not a function of anything. This is a number. It's a constant. The natural log of 2 is a number. Okay? And if you know that the natural log of, I think, 0.6 something, okay? 693, okay. Now, so this is a number. So you have to view this as if this is just a function being multiplied by a number, say 2 or 3 or 4, okay? Now, so we're going to leave this as a constant and just differentiate this, but we need to differentiate this too. So let's differentiate both sides. Let's see what happens. Now, if I take the derivative, okay, I say d dx of natural log of u, I'll have to differentiate this. But because this is a number, I may as well put the number here and say this is just natural log of 2. Then I have d dx of the square root of x. So with this, I now need to differentiate this. Remember that this could be written in exponent form and it makes life a lot easier for everybody. So let's write this here. I wrote it while you weren't watching. Okay, now you see I have rewritten this expression as this, and now it's easy to differentiate. Remember, this is a number, so don't bother yourself with working with this. So now, how do I differentiate natural log of u? We know the derivative of the natural log of x is just 1 over x, okay, times the derivative of x, but the derivative of x is 1. But in this case, it's going to be 1 over u times the derivative of u. The derivative of u is du dx. Why? Because we said u is a function of x. So we're going to use implicit differentiation. So you should not be attempting this problem if you don't know implicit differentiation. So I'm sure you're doing calculus 2 because you already know implicit differentiation from calculus 1. Okay, so let's go to the right hand side. The right hand side, I'm going to leave this number here, just natural log of 2. But what's the derivative of x to the 1/2? It's going to be times 1/2, then x to the 1/2 minus 1, negative 1/2. So if you observe, it looks like we can write this as a natural log of 2 divided by 2 times, this is going to be 1 over the square root of x. And here on the left hand side, we have 1 over u times du dx. Now what are we looking for here? I need to be able to replace this expression, because you see this integral here can be written as the integral of u, because we already said u is this. Okay, so see what's going to happen. I'm going to need to generate something that looks like this. This is the main focus. I need to generate this. 1 over x dx. Well, I can put this dx here so that what I have here, and I can move this to this side and watch what we're going to get. If I multiply this by 2 and I multiply this by dx, or I move this dx here, okay, what I'm going to end up with is going to be this natural log is going to come down. This is just algebra, okay? So this is something you should be able to take care of by yourself. So I'm going to multiply both sides by 2, multiply both sides by dx, divide both sides by natural log of 2. So I'm going to end up with 2, watch this, 2 over natural log of 2 times 1 over u du equals, this 1 over x stays here, 1 over square root of x, and this dx goes here, it's going to be dx. Perfect. Looks like this. So I'm going to go to this integral now and then replace 1 over square root of x dx with this entire expression and see what it's going to be. So this expression now looks like this. This is equal to the integral of u, remember u is this, times this. But 1 over square root of x dx is equal to this whole thing. So I'm just going to write this, 2 over natural log of 2 times 1 over u du. Do you see the beauty we just created? This u is going to cancel this u out, and what you have left is just 2 over natural log of 2 du. So we're going to have the integral of 2 over ln of 2 du. This is a number. If you integrate this, your answer is going to be 2 over natural log of 2. You introduce a u plus c. That's it. Remember, when you integrate a number, you just introduce back whatever the variable you're integrating with respect to. So if I say what is the integral of 2 dx, your answer is going to be just 2x plus c. What is the, so this is a number and that's it. So but what did we say u was again? U is 2 raised to power square root of x. So we're going to rewrite this and say this is equal to, I need to write well. This is going to be 2 over natural log of 2 times 2 raised to power square root of x plus c. Now, can we leave our answer like this? Yeah, it looks messy. But you know that you can combine this 2. This is 2 raised to power 1 times 2 raised to power square root of x. And laws of exponents say you can add these two exponents together. So you see that your final answer could actually look like this. Could be 2 raised to power 1 plus square root of x divided by the natural log of 2 plus c. And this is what I would write as my answer. Never stop learning, because those who stop learning have stopped living. Bye-bye.